Hello everyone. Today we're going to go over a few examples from the skill area and circumference of circles challenge. Okay, so you might want to have your circles reference sheet handy with the formulas. That will definitely be helpful to have during while you're working on this skill. So let's try the first problem. It says an artist is creating a large butterfly sculpture outside a museum. There is a circular dot on each wing made out of a metal ring. The distance around each dot is 24 pi inches. The artist plans to fill the inside of each dot with blue colored glass. What is the area of the blue glass that will be needed to fill each butterfly dot? So the first thing that you should pick up from this problem is that they're telling you that the distance around each dot is 24 pi inches. We know the distance around refers to our circumference. So as you can see right here, I've got C equals 24 pi. Now remember, your circumference formula is C equals pi times diameter. So that means that since this is written in terms of pi, 24 pi, that means your diameter has to be 24. If your diameter is 24, your radius will be half of that, which gives you a radius of 12. Now we have everything we need to find the area of the blue dot. Notice it does say to give your answer in terms of pi. So we're going to leave our answer in terms of pi. Here is my area formula. A equals pi times my radius squared. My radius is 12, so 12 squared is 12 times 12, which is 144. So our total area in terms of pi is going to be 144 pi inches squared. Let's try another one. You are going on a field trip in a school bus. A special detector placed on one of the bus's tires counts the number of rotations completed by the tire during the journey. The tire's diameter is 1 meter and it made 8,000 rotations during the trip. How far did the bus travel? And again, we're giving our answer in terms of pi. Now we learned during the circumference and rotations skills that one rotation is equivalent to the circumference of your circle. They're telling us the diameter is 1, so I've written that down. And the circumference, which is equivalent to one rotation, pi times diameter, and then we're going to multiply that by 8,000 because it's making 8,000 rotations. So our diameter is 1, so I'm going to plug that in. 1 times pi is 1 pi, and then 1 pi times 8,000 is going to give us a circumference of 8,000 pi meters. And that would be our answer in terms of pi. Okay, let's try this one. It says a park has a large circle painted in the middle of the playground area. The circle is divided into 4 equal sections, and each section is painted a different color. The radius of the circle is 10 meters. What is the area of each section of the circle? Okay, so our radius is 10. So as you can see, I've written that down at the top. Then I'm going to write my area formula, which is A equals pi times the radius squared. We only need to find the area of one section of the circle. And since it's divided into 4 sections, that means that once we find our area, we just need to multiply that by 0.25 or 1/4. So that's what you can see here in my area formula. I've written A equals pi r squared times 1/4. My radius is 10, so I'm going to plug that in. 10 squared gives me 100. So that leaves us with 100 pi times 1/4, or 100 pi over 4. And if I find a quarter of 100, that's going to leave me with 25. 100 divided by 4 is obviously 25, and that leaves us with a total area of 25 pi meters squared. Let's try another one. It says when the radius of a circle is multiplied by a factor of 3, by what factor will the area of the circle change? This one can be tricky. Okay, so I'm going to do this as a hypothetical. So let's say my radius is 1. Okay, let's calculate our area with a radius of 1. So A equals pi r squared. There's our formula. And then obviously if I plug my radius in, 1 squared leaves me with an area of 1 pi. Okay, now they're saying what happens if you multiply by a factor of 3? Well, if I take my initial radius of 1 and multiply that by 3, that's going to give me a radius of 3. So now let's plug that into our area formula. A equals pi r squared. 3 squared gives me 9 pi. So that's going to give me a new area of A equals 9 pi. So clearly I can see in my hypothetical example here, starting with a radius of 1 and multiplying it by 3, you can see that now my area is 9 times bigger. So that means that an area with a circle of a radius of 3 is going to be 9 times as big as the area of a circle with a radius of 1. Okay, the correlating note-taking packet pages for this section are pages 14 through 16, top of the page. And again, you can watch additional examples in Khan Academy. Please feel free to email me with any questions, or you can ask any questions in the Google chat. I do plan on going over this skill in the Zoom session on Wednesday morning this week. Have a great day, everyone.